I am 303. Warning. Yeah, you know. At the end of part 1, this was the metallic pyramid that we were left with after our second smelt. Here we are a couple of days later, and here's all the materials that we had from our last smelt. The metallic button that we created, the metallic pyramid, appeared to have oxidized, and instead of being shiny and metal looking, it turned black, and it's also brittle. You can practically crush it with your fingers. And this is the point of the pyramid that appears to have the silver from the smelt in the point, and that broke off pretty cleanly. It still has some stuff stuck to the top of it, but not really too worried about that because we're going to put it in with the next run. So we started off with an estimated almost 19 grams of silver from the sterling and the powder silver that we used. And we should have had about 25 milligrams of gold or so in there. This only weighs 10 grams. So that means there's probably about 10 more grams in this material. Now, what I think happened is with the addition of the sulfur, we turned those base metals into sulfides. And I don't know if you can see the grain structure in there, but that could be any number of different sulfides from the base metals. And one interesting thing about this material is it's very slightly magnetic. It's not as magnetic as like a piece of iron, like a nail or something, but it's definitely still magnetic. The silver button, the collector metal button that we have, is not magnetic at all. So after all this was busted up, we have about 29 grams there. So that's 39.38 grams. I may have picked up a little bit of extra slag because we were only at like 38 when we got done with the melt before, but now we have about 40 grams of material. We started with 70 grams of material between the gold plated stuff and the silver that was in there, but let's say if we were down to 40, that means that 30 grams of the base metals were in here in the glossy slag. And this could possibly contain some precious metals that got stuck in the slag, but I really don't see any evidence of that in the slag itself. Although if it's microscopic, you wouldn't see it, and that's why we're saving it. I want to take this material that I believe is sulfides that we created from adding the sulfur, and I want to try to crush it up as fine as I can get it so that we can mix it in with the flux and try to get a good melt on this stuff. Get a good smelt so we get a chemical reaction going between the flux and whatever's in here. Okay, so here we have all of the crushed up sulfides. All right. And here, this is 5 grams of already weighed out potassium nitrate. And we're just going to put that right in there with that. Also here, we have some silica powder. This is already weighed out at 10 grams. We're going to put that right in there as well with that. And we're going to add a lot of borax. Okay, so we got a little over 50 grams there, so we're going to go with that. Looks like about 52 grams. This time, instead of adding something basic, instead of adding the lye, we're going to use fluorspar. And we're just going to use a very small amount of this to see if we can make this pour nice and fluid. Oh, that's probably way too much. All right, so we got a little over 2 grams there. We'll go with that. A little goes a long way with this stuff, and it's expensive. And then we're going to double down on the silver. This is more silver powder. I want to make sure that we have plenty of silver in there to act as a collector metal. And since that solid piece is already solid, I want to make sure that we have some free-form silver in there. So this is just over 10 grams of silver powder that we're going to add. This is cement silver from some gold refining. And then we'll get this all mixed up and get it down in the crucible. And then this will be our charge for this smelt. I really hope that the crucible can maintain, because it does have some stress marks, but I don't think it'll fail. I think it'll make it through this smelt okay. It might be its last use, but I think it'll make it through it. All right, that seems to be pretty well mixed up. And then what we're going to do is put this piece right on top. So hopefully it'll stay suspended there and then pull the molten metals down when it drops to the bottom. Now we got it in the furnace. And we got it fired up. Everything started off nicely, and we got our cone mold reset. And here you can see there's a really good chemical reaction going on inside of the crucible. Unfortunately, shortly after this, everything that could go wrong did go wrong. It started to rain, and I noticed that there was a crack in the side of the crucible, meaning that it was going to fail. So I had to hurry up and pour it. So I could only run the smelt for about 15 minutes when I wanted to do at least a half an hour. And here you can see the crack in the side of the crucible. I was lucky that I caught it in time and was able to make the pour before it failed completely and I lost the charge. It cooled off. I took it out and busted off the slag, and this is the pyramid that we were left with. And it weighs 43.35 grams. So we started off with 50 grams of gold-plated scrap, and we added 20 grams of silver. Some of it was the silver powder, and then some of it was sterling silver. So we started off with 70 grams. After the first 2 smelts, we were left with, it was like 39 point something grams, so we're just going to call that 40 grams left. So if you subtract that, that gives us 30 grams, which means that we took out about 15 grams per smelt. After that, we added 10 grams more of powdered silver, which would give us a total of 30 grams of silver in the batch. So we had 40 grams, and then we added 10 more grams, so that would have been 50 grams before this, and now we have 43 point something. So we took out about another 7 grams in this last one. Now my guess is that if we would have been able to, if the crucible wouldn't have failed and we would have been able to let that react for longer, that it probably would have taken out more. It would have oxidized more of the base metals and taken out more than just 7 grams. But now we have a little over 43 grams of metal to deal with. And we know we should have about 30 grams of silver. And our estimated gold content was just 25 milligrams. So that would be not much, but it should be in there somewhere. And then some of this may be copper. Some of it might be nickel. Some of it might be cobalt. And some of it might be iron. If there was anything more reactive than iron, it should be gone already. And more than likely, most of the iron is gone because of these 4 metals, that's the most reactive. So more than likely, most of the iron, if not all of the iron, is gone. Could cobalt and nickel still be in there? I believe so. Could copper still be in there? More than likely, because we know there was some in the silver that we started with. And judging by the color of this, it does have a slightly bluish appearance. That leads me to believe that maybe it has cobalt in it, and maybe it has copper in it, because if it was just nickel and silver with a little bit of gold in it, it would probably be more silvery in color and less of this bluish color. I really wanted to do more with this. I wanted to do another smelt tonight, but unfortunately it's raining, and I think I'm going to wrap this one up here and call this part 2 and maybe do a part 3. I just wanted to touch on a couple of things before I end it. So this, although it probably contains nickel, cobalt, or maybe even some iron, it's no longer magnetic. It's not magnetic at all. So if it does have these metals in it, the percentage of silver is too high and the percentage of these metals is too low in order for it to maintain its magnetism. It just slides off. Another thing is, since we know we started with 30 grams of silver, well, actually maybe it's like 28.5 grams of silver. That means that all of this, if we're down to say 43, we're looking at about 15 grams of all these metals combined left in this. And I would say our first 2 smelts were pretty successful because we were able to take out 15 grams per smelt into oxidized metals that we got into the slag. The last one was only moderately successful, but with the failure of the crucible and the reduced amount of time, I don't feel like we got a really good indication of what that would have been, since that one was without the sulfur and mainly just focusing on trying to oxidize the metal. And I wanted to stress again that, the silver that we started with, some of it was sterling and some of it was pretty pure powder. So there really wasn't much sense in adding this in except as a collector metal. Refining it would be really easy with nitric, and precipitating out on copper and possibly running through a silver electrolysis cell. 25 milligrams of gold is only worth a couple of US dollars. So there's not really a value in doing this process, but the value to me is understanding what's going on with this process to see if it's viable in case you have other materials that contain ferromagnetic materials. I actually did a batch of gold-filled scrap that was magnetic, and it had nickel in it, and that was really hugely complicated because I had to dissolve the nickel and the gold together in aqua regia because the nickel was just too resistant to do in just a dilute nitric acid boil. It still stayed behind. And I didn't film that one. I wish I would have, but I didn't have the time. It's really not economically feasible because I actually got another one of the same crucibles that that failed, and these are like $15 a piece. So that's definitely not worth a failing crucible for 25 milligrams of gold, and that doesn't count the fuel that was used or the flux material that was used. But if you were to scale this up, if you were to have something that was, let's say, gold filled and had more of a gold content, then maybe this would be a viable option. Thanks for watching. The end.